Hi students, this is lesson 6.1, Angles of Polygons. And to find and use the sums of interior angles of polygons is our goal. So where do we start? Well, let's start by talking about diagonals. Diagonals from a point are the segments that connect any non-consecutive vertices. So P to S or P to R, but we couldn't put P to Q or to T. So in the case of this pentagon, there are two diagonals. And the interesting thing is those diagonals have a relationship with the sums of interior angles because diagonals form triangles. So quadrilaterals form 2 triangles, pentagons form 3, hexagons 4, and so on. So here's the deal. Triangles have 3 sides, 1 triangle, so the sum of their interior angles is 180. Quadrilaterals have 4 sides, but 2 triangles, and the sum of their interior angles is 360 because we have 2 triangles, 2 times 180. And the pattern continues for pentagons, hexagons, and up to any possible polygon. So here's the formula. However many sides you have, or however many angles you have, subtract 2, and then multiply that number by 180. If you need a reminder for how we name shapes, here is a reminder. You could name many other shapes, so feel free to look up those names using Google. Let's look at our first example. Find the sum of the measures of the interior angles of a convex heptagon. So heptagon means how many sides? Heptagon is 7. All right, so we're going to use that theorem we just came up with. So 7 minus 2 is 5, so we're just going to do 5 times 180. So the sum of all those interior angles is 900. What about here if they ask us to find the measure of each interior angle of a quadrilateral? Well, let's first remind ourselves what the sum of all the angles of quadrilaterals is. So we're going to do 4 minus 2, which is 2 times 180, or 360. So quadrilaterals will always add up to 360. Then we're going to write an equation for the sum of these 4 angles to equal 360, and I know you can do that part. I know you're great at solving for x. And then once we have x, I know you know what to do. Plug x in to find those missing angles. Example 2 asks us to look at the poles for a tent that form a regular hexagon, and that word regular means that all of the angles, all of the sides are equal. When the poles are properly positioned, what is the measure of the angle formed in the corner of the tent? So we need to think of what hexagon means. Hexagon means 6 sides. So we're going to do 6 minus 2 times 180 to get 720. And if they're positioned correctly, we're going to be able to divide the 720 by 6 to find what each angle will be, and it will work out that each angle is 120. Example 3. The measure of the interior angle of a regular polygon is 135. Remember, regular means each of the angles, each of the sides will be the same. Find the number of sides of the polygon. So this time we're going to work backwards. So we know that 135 times however many sides will equal the formula that we've learned about, and then we're going to solve for n. This time we have n on both sides of our equation, so we need to do some distribution and then subtract 180n from both sides to get all the n's to one side, and then divide by negative 45, which tells us that this figure will have 8 sides. Take a moment to look at this. Do you notice a pattern when you look at the sums of all of these exterior angles? What do they all equal when we add them up? 360. So that's our next theorem. No matter what number of sides or angles a polygon will have, when you add up those exterior angles, they will always add to 360. So using that theorem, Example 4 asks us to find the value of x. So we're just going to add up all of these sides and say it equals 360 and solve from there. So it's just algebra.